So today we're going to be solving the mock test for the Math 2 final. Let us dive into it straightforward by solving the very first question. So the first question that we have here is this. By applying Kirchhoff's voltage law to a circuit, the following differential equation has been obtained. 2d2y by dx squared plus 5dy by dx minus 3y equals 0. Determine the general solution. So first thing we need to find general solution, and then we need to find the particular solution given our initial values or boundary conditions. All right. So again, the way to solve this is the first thing we need to do is find our auxiliary equation, meaning that I can rewrite first before finding our auxiliary equation. We can rewrite this as 2y double prime plus 5y prime minus 3y is equal to 0. As you remember from older sessions, the way you get your auxiliary equation is you're just going to put r squared instead of the double prime plus r instead of single prime, and then if you just have y, you're just going to keep the coefficient by itself. And now we have a simple quadratic equation that we can solve. Okay, so how do we solve this quadratic equation? Simply, we use our quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac divided by 2a. All right, where this is our a value, this is our b value, and this is our c value. All right, so this is equal to negative 5 plus or minus the square root of b squared, which is 5 squared, which is 25, minus 4 times a, which is 2, and c, which is negative 3. Remember, you have to include the sign as well, divided by 2a. Simplifying this, we will get, so 4 times 2 times negative 3 is negative 24. 25 minus 24 becomes 25 plus 24. We will get minus 5 plus or minus the square root of 49 over 2a. Again, we can just replace the a from the beginning as 2. This is a, so this is going to become 4 down here. All right. So this is the first step you do. Once you notice that in this case over here, we have under the square root a positive value, that means we're going to have two real distinct roots. All right. So that's the case that we will be dealing with, where we're going to have two real distinct roots. So R1 is going to be equal to minus 5 plus the square root of 49 is 7 divided by 4, and R2 is going to be equal to minus 5 minus 7 over 4. All right, so R1 is going to be equal to 7 minus 5 divided by 4, that is 1. Wait, is that right? 7 minus 5 divided by 4, that's half. Yeah, 1 over 2, 0.5. And R2 is equal to minus 5 minus 7 divided by 4. This is going to be negative 3. So these are our distinct roots. Since we have distinct roots, we can go and refer to the formula sheet, or if you guys already know it, the general solution y is going to be equal to e to the power of, actually it's going to be c1 times e to the power of r1 x plus c2 e to the power of r2 x. Okay. So what does this mean? We're going to be plugging in our R1 value and R2 value here to find our general solution for this question. This question was given in dy by dx form, so yes, so we keep it as dy and dx, so we keep it in y and x. It's going to be c1 e to the power of R1, which is 0.5 x plus c2 e to the power of negative 3 x. Again, it doesn't matter if you chose this as your R1 or this as your R2. You just have to put them in your general solution. But once you put them in your general solution, that will be your final solution, so you cannot swap them around afterwards. All right. So once you plug it in, this will be now your general solution. What do I mean by you cannot swap them? Now, when we want to solve for the particular solution with the given boundary values, خلاص, we have to keep the solution مال general in this form. We do not change the locations of anything else. So now we are given that at at when x was equal to 0, y is equal to 4. This is our first boundary condition, or our first initial values. And when x is equal to 0, dy by dx, or in other words, y prime, is equal to 9. All right, y prime, this is just the notation. Don't get confused. It's the same thing as dy by dx. All right, so now what do we do? This is our second case. So let me color code these actually. So this is our first case, and this is our second case. All right. So if we go back here, just so you know where I got these values from, it says when x is equal to 0, y is equal to 4, and dy by dx is equal to 9. This is where I got these conditions from. Now we're going to take a look at our general equation. All right. So this equation is what we found, our general solution, I should say. So for the first case, we can directly plug in. So for our first case, we know that x is equal to 0 and y is equal to 4. So we just plug in these values for the equation above. So our y is equal to 4, which is equal to c1 e to the power of 0.5 times 0, which is x, plus c2 e to the power of negative 3 times 0. All right. Now we can solve here. We can simplify it. So 4 is equal to c1 e to the power of 0.5 times 0. That's e to the power of 0, which is 1, plus c2, again, e to the power of 0 is just 1. So our final equation is 4 is equal to c1 plus c2. If you notice here, now we have one equation, but we have two unknowns. We cannot solve this directly. That is why we have two initial conditions, so that we can find a second equation. وبيكون عندنا two unknowns and two equations to solve for it. So I'm going to just call this equation number 1. So you don't think it's a negative sign. This is equation number 1. All right. Now we need to find out a second equation so that we can solve for our constant C1 and C2. That is the idea of solving for the particular solution. We are trying to find out the values of C1 and C2. But the second one, we have y prime instead of y. So we cannot just plug it in back into the equation. What do we need to do? We need to find our y prime. So now, this is our general solution. We need to find our y prime. So we have to differentiate. Y prime is going to be equal to the differentiation of the first one. Remember, C1 is just a constant. E to the power of 0.5, so we multiply 0.5 outside. C1 e to the power of 0.5x, plus the same thing we do here. From plus, it's actually going to become minus 3c2e minus 3x. We are just doing the differentiation, which you guys should all be familiar with now. So now we have found our differential or differentiated equation. We can take our boundary conditions here, which is x equals 0, y prime equal 9, and plug them in. So x equals 0 and y prime is equal to 9. We're going to plug them into this equation. So y prime is equal to 9. This is equal to 0.5 c1 e to the power of 0.5 times 0, which is the value of x, minus 3 c2 e to the power of minus 3 times 0. All right. Simplifying this equation is going to give us 9 is equal to 0.5 c1 times 1, e to the power of 0 is 1, minus 3c2 times 1, because e to the power of 0 is 1. Further simplifying it, we're going to have an equation that is simply 9 is equal to 0.5 c1 minus 3c2. So this is our second equation now. This is equation number 2. If we bring back equation number 1, we're going to have a simultaneous equation. What does that mean? And after we have two equations with two unknowns. All right. So we can use these two equations now to find C1 and C2. For me, I prefer, there are definitely multiple ways to do this. You can do it through matrix. You can do it through substitution or elimination. That's up to you. I personally prefer for this case to use substitution as it's the easiest. So the first thing I'm going to do is I'm going to rearrange equation 1 and keep C1 by itself on one side. All right, so C1 is equal to, I take C2 to the other side, it will become 4 minus C2. All right, this is still the same equation, I just rearranged it. Now I am going to be substituting my C1 here, the value, into my equation 2 C1. So I can solve and find the value. So it's going to be 9 is equal to 0.5. The value of C1 over here, which is 4 minus C2 minus 3 C2. And we solve for C2 now, just basic algebra. So 0.5 times 4, that's 2. 2 minus 0.5 C2 minus 3 C2. 9 is going to be equal to, actually, I'm just going to take the 2 to the other side from now. So it's going to be 7 is equal to negative 0.5, and negative 3 becomes negative 3.5 C2. Therefore, C2 is going to be equal to 7 divided by negative 3.5. Yani our C2 is equal to negative 2. And this is our first value for C2. Okay? Now that we have found our C2 value, we are going to plug this back into equation 1 so we can find C1. So now we want to find C1. C1 is equal to 4 minus C2. 4 minus C2, which is negative 2. All right, this is from equation number 1. Therefore, we know now that our C1 is equal to 4 minus minus 2 is simply 6. Okay. With this being said, now we have our C1 and C2 values. We can take our general equation and it will become a particular equation because we can remove now the C1 and C2 and put actual values instead. So C1 is equal to 6 and C2 is equal to negative 2. So this will go from plus and will become minus 2. And this is going to be your final particular solution. All right. So this is our particular solution. Okay. Already done this a lot of times. I'm pretty sure most of you don't have any issues with this. Let me see if you guys have any questions. Yes, you can do that basically, Ryan, as you said. Look, when it comes to simultaneous, you can use any method, but most of the time you'll be able to do substitution directly in the same way I did here. You're almost all the time, all right? Okay, so let's move on to the next question. The next question is a higher order differential equation. So we have done the second order. Let's do a higher order differential equation. And if you notice here, it just says solve the differential equation, meaning finding the general solution, not finding any particular solutions because they did not give us any initial value problems. So again, first thing is our auxiliary equation or our characteristic equation, which is going to be, in this case, we usually use lambda to the power of 4 minus 7 lambda power 3 plus 11 lambda power 2 minus 5 lambda يساوي 0. If you notice from the very beginning here, when we want to solve this, lambda can be taken out as a common factor because it is available in every single component or element. So we can take it out as a common factor, and we will be remaining with lambda 3 minus 7 lambda squared plus 11 lambda minus 5 equal 0. So we know from now that our first root, lambda 1, is equal to 0 because of the lambda we have outside. What do we mean by this? The whole idea of finding roots is finding what will make this equation be equal to 0. بما معناه, if I plug in 0 into my lambda, I am going to get the solution to be 0. This is what we are trying to achieve here. So the first thing we notice that if we multiply 0 with all of this, we're going to get a value of 0. So that's our first root taken care of. Okay? Now there are multiple different ways of finding out the root of these. Me personally, I prefer the trial and error method because it just makes life so much easier for me. So what is the trial and error method? If we're looking just at this, we're gonna look at all the factors of 5, which is 1 and 5, and -1 and -5. Okay? And then we're going to be plugging this into this cubic equation. So now we are doing something called trial and error. And we're going to plug it in until we get a value of 0. So let's try with 1. Let's start with the simplest one. So when lambda is equal to 1. In other words, what do we mean? We mean that the factor of it is lambda minus 1. Okay, this is what lambda equal 1 is. All right, because if we plug in this one into this equation, we're going to get this as 0. All right, so when we have 1, how do you find out if this is an actual root or not? First, we're going to write down this equation again so that you guys can see how it will be solved. So we're just looking at the cubic, right? First thing we're going to do is lambda cubed becomes, we're going to write down their coefficients. So this is 1, -7, 11, and -5. All right. And we're going to put in our factor that we are testing over here. So this is going to be 1. Okay. First thing we're going to do, the first one, we're just going to bring down. Now we are going to do something known as multiplication, or known as a shortcut of long division. All right, this is what it is. I forgot the actual naming of this, but it is a shortcut of long division. So we're going to do multiplication here between this one, and the answer is going to go here. So the answer is going to be 1. 1 times 1 is 1. And then we're going to be adding these two values together. So -7 plus 1 is -6. And then we're going to do the exact same thing again. All right. Before that, actually, the trial and error method, what you are supposed to do is you're going to substitute the 1 into your lambda here to know whether or not it is an actual root or not. So before I even continue this, I will re-explain this. First, let's check if this is actually a root. So to check, we're going to put 1 cubed minus 7, 1 squared plus 11, 1 minus 5. And then we want to check if this is equal to 0. All right. So we get our calculator. We're going to do 1 minus 7 plus 11 minus 5. And what do you know? We get 0 equal 0. That means this is actually a root. Okay. So now we can move on with this method. Yani first check if this is actually a root. Will you get 0 when you plug in this value? Once you do, then you're going to do this table method to factorize the remaining parts, and I will show you that in a bit. So like I said, we start with 1. We write the coefficients down. 1 times 1. Find the answer, put it in the next place, add them up. -7 plus 1, we get -6. Again, the same thing is going to happen. We're going to put this over here. So this is equal to 1 times -6 is simply -6. Again, what we're going to do is we're going to add this with this. So 11 plus -6, or 11 minus 6, that is going to be 5. All right. Again, we're going to do this one last time. We are going to take this and we're going to multiply, right? Just like we did earlier. 1 times 5 is 5. 5 is going to be put here, which is like that. And then we're going to add one last time. And you have to get a value of 0 over here. If you do not get a value of 0, because this basically means it's your remainder. If you do not get a value of 0, just know that you made a mistake while finding your lambda. So it basically is not actually a root. Or maybe you have made a mistake in the calculations here if you are sure that it is a root. So why are we doing this? Because like I said earlier, we have lambda minus 1. And we want to know what will be remaining once we take this lambda minus 1 outside of this equation, which is lambda cubed minus 7 lambda squared plus 11 lambda minus 5. So this is what will be remaining, where this is going to be your lambda squared. This is going to be your lambda squared. This is going to be your lambda. And this is going to have no lambda, just the number. How do I know this? Because we started with cubed. So the next number is going to be squared. All right, because we took out one lambda. So the cubed is going to go away. The next highest order is going to be squared. So we'll be remaining with lambda squared, or I should say 1 lambda squared, minus 6 lambda, plus 5 and by itself, and this should be equal to 0. And of course, you should not forget the lambda that we had from outside from the very beginning. This was just the analysis of the cubic, but we also have one more lambda outside, which is over here. All right. So now we have found two factors. We found lambda 2 is equal to 1 as a root. All right. So first we found our lambda 1, which is equal to 0 as a root. Now we found lambda 2 is equal to 0 as another root. Moving on, we are gonna now analyze the quadratic, which is very easy. The way to do a quadratic is straightforward, like we do for second order. So if we just look at the quadratic part now, so lambda squared minus 6 lambda plus 5 is equal to 0. The way we do this is lambda 1, 2 is equal to minus b, which is minus 6, plus or minus the square root, just like we did for the second order. The square root of b squared, which is 36, minus 4 times a, which is 1, and c, which is 5, divided by 2 times 1. Again, you can use mod 5-3. I'm not sure if they're going to deduct marks or not, but I'm doing the full way just in case you have to show steps. All right. So once you do this, you're going to have lambda 1, 2 is equal to, simplifying, this is going to be 6 plus or minus the square root of 36 minus 20 is 16 over 2. All right. So since again we got a positive value here, we know these two are going to be real distinct roots. Okay. Meaning that lambda, I'm saying 1 and 2, but we actually mean lambda 3 and 4 because we have found our lambda 1 and 2. So I'm going to call these lambda 3 and 4. 3 and 4. It's going to be equal to, let's just have lambda 3 is equal to 6 plus square root of 16 is 4 over 2. And lambda 4 is equal to 6 minus 4 over 2. All right, simplifying this, we're going to get lambda 3 is equal to 5 and lambda 4 is equal to 1. So now we have found all of our roots for the system. So our lambda 1 that we have found earlier, lambda 1 was equal to 0. Lambda 2 was equal to 1. And now we found lambda 3 is equal to 5. And lambda 4 is equal to 1. So how can we write our characteristic equation now? First thing you need to notice here is we have a repeated root. We have lambda 2 and lambda 4. They are both equal to 1. So these two, they're going to be the case of repeated real roots. All right. And these two, the 3 and the 5, they're going to be the case of distinct real roots. So if we look at our general solution now, y is equal to let's do the way you will do this here is first you will fill out all your distinct real roots to begin with to make sure that you are getting them out of the way, and they are the simplest to do. So the equation for that is C1 e to the power of lambda 1x, or in this case, actually let's keep it as lambda 1x, plus C2 e to the power of lambda 3x. All right. So we have our general solution. This is for when we have the first case of distinct real roots. Now, plus C3 lambda 2, we have repeated roots. So what is going to happen? The first one is going to be lambda 2 to the power of x, and the last one is going to be C4 x e to the power of lambda 4 x, because this was the rule for repeated roots. So again, what I did here is I applied the distinct rules here, the distinct roots rule here, and for this part I applied the repeated real roots here. And this is how you will get your general equation. Now all you're going to have to do is substitute for your lambda values. So C1 e to the power of lambda 1. Lambda 1 is 0, so it's e to the power of 0 times x, plus C2 e to the power of lambda 3, which was 5x, plus C3 e to the power of lambda 2x, lambda 2 was 1x, plus C4x e to the power of 1x, which is our repeated root 1. Simplifying this one last time, e to the power of 0 is just 1, so it's going to be C1, plus C2 e to the power of 5x, plus here what is usually done is they take E1x as common and leave it outside. So it's going to be C3 plus C4x e to the power of x. And this is your final general solution. So this is your general solution. Okay? Clear? Any questions about this? Could you clarify how? In the mock paper, I think they tried to find a way where they did the factorizing by splitting pieces into pieces, but I do not recommend using that method. Another thing you guys can do instead of this is you guys can do long division instead. So basically you can take this and divide x minus 1 and then do that. But my recommendation is get used to this method. It's the quickest, saves most time, have least errors due to it and all of that. So just make sure you know how to do this method. وبعدين تطبقون. أهم شيء you understood the solution, what I did, right? So how did I1 become... Okay. From the very beginning of the question, we took lambda out as constant. Tamam? When we take lambda out as a constant, this is going to be a 0, one of our roots. يعني بما معناه if we plug 0 into lambda, we are going to get 0 as our final answer. So it is our very first root. Then, once we got our lambda 1 equals 0, the next step is to find for the cubic inside. And for the cubic inside, the way you do it is you take the factors of the very last number you have. You have 1 and 5, which are your factors, the positive and the negative values. You will plug them into this equation. So that's what I did. يعني في lambda cubed minus 7 lambda squared plus 11 lambda minus 5, I plugged in lambda equal 1. Once you plug it in, if it is 0, معناته that this is a correct and actual root. If not, you're going to move on to the next value, and at least one of them will be a root. All right? Once you have done that and you have confirmed that this is a root, you're going to use either this method or long division to figure out what is the remainder of this root or what is remaining to factorize. زين؟ فمعناته, if you have 1, this means lambda minus 1 is a root. Therefore, lambda into lambda minus 1 will keep outside, lambda from the very beginning and lambda minus 1 that we have just got here. And then the answer from this is going to be your remaining quadratic equation. بعدين you just apply the same exact thing we usually do for second order. Once you do that, when it comes to the solution, you check what type of roots you have, whether you have any repeated, whether you have any distinct, whether you have complex, repeated complex, whatever it is, just make sure you're applying step by step the case for each one. يعني for distinct real roots, that's the first thing I did. And then once I did that, I plugged it in, done. Then I looked at my repeated roots and then I just continue. So our constant here was 2. The next constant will be 3. The next constant will be 4. And then That's how it is. The constants will always be يعني whatever it is in order. And then I just plugged in my values for each one, and then I have found my general solution. Insane. A lot of people are talking about using mod 5.4. You can use mod 5.4, you can. There is nothing wrong with using mod 5.4, but again, I do not believe يعني they will give you the full mark if you just put mod 5.4 because it will give you the roots directly. Okay? This is how you factorize for a power 4. And I'm going to go more directly. You're going to use the exact same method. So instead of 3, you're going to have 4 here, and you're going to apply the same exact method of trial and error if this was power 4 as well. The same exact method, okay? But when we see a question like that later on, we'll talk about it. For now, this is the general solution for this question, okay? Again, you just make sure you're following your steps very clearly, and you'll be fine, all right? No, we did not, but we will do soon, inshallah. And then let's look at the next question. Let's move on with the mock test. So now this was our ordinary differential equation questions. Let's talk about the statistics and probability questions, which is going to be half your exam, by the way. So half the mark is going to be on this, the ODEs, and the other half is going to be probability. All right, probability and statistics, I should say. So this question says, a box contains 4 brass washers. Where did my pen go? There it is. So a box contains 4 brass washers, 86 steel washers, and 40 aluminum washers. معناته even before I do any calculation for probability, the first thing I do is I understand my box. فإحنا عندنا box. We have 4 brass. زين. We have 86 steel. And we have 40 aluminium. معناته how many total washers do I have in this box? The total number of washers is 4 plus 86 plus 40. This is the first thing you're going to find. The total number of sample or the total sample size. So it's 4 plus 86 plus 40. So your N is equal to 100 and 4 brass 86 plus 4 plus 40 مخي ضرب 130. Yes. So you have 130 total washers. All right. Now, we know how to find our total washers. We can also find the total probability of these washers. So what can we do? The probability of taking one brass washer, so probability of A, actually let's keep it the same letter, so B, which is for brass, is 4, the number of brass washers we have inside, divided by our total 130. So this is our first probability. Our second one is for steel. The probability of steel is equal to 4 over 130 for steel. It's going to be 86 over 130 because we have 86 washers. All right. And the last probability is of aluminum. So probability of aluminum. Oh, aluminium. It is 40 over 130. Then, before even reading the question, then I need to understand what I am dealing with. I need to know the probability of picking one. This is just for one choice of this, of brass or of steel and of aluminum. I need to know how many total washers are inside so I can have a general idea of what it is. Now let's see what they want. They are going to pick 3 washers are drawn at random. So it's very important to know that you're going to have 3 choices. So معناته you're going to have your first, then your second, then your third. Then washers are drawn at random from the box without replacement. The most important thing here is without replacement. What does without replacement mean? When you read without replacement, it means without replacement. معناته it is a dependent probability or a dependent event. What does this mean? This means when you take one brass outside, and then let's draw the 4 brass just for example purpose, and then So once you take one brass outside, for example, all of your numbers are going to change here. So if I want to copy paste this down so I can show you how it will look like. So let's say, for example, that one of the brass has been taken out. Okay, so one of the brass has been taken out. Now your new value is no longer 4, it is 3. So here this is going to be 3. So your new total is going to be 129. All right, this is just an example. Okay, this is what is meant by without replacement. إن يوم طلعتوه ما بترجعونه داخل خلاص. All right, now I know they said 74 or whatever. It's fine. عادي. It's fine. I'm just trying to explain the concept. All right. So let's say now let's read what the question actually wants. Like I said, it wants to determine the probability that all of the washers, all three are steel washers. So all of them have to be steel. معناته the first pick, what should it be? It should be steel. So we're going to find the probability of, so this is first, second, and third. Let me make some space. And let me take them a bit more down because I want to bring the picture and put it down here as well. So now, so you can understand what's going on. I'm going to remove this. And our n, I'm going to keep it underneath over here. Then, so for our first case, our second case, and our third case, or I should say our first choice, second choice, and third choice. Remember that we want all of them to be steel washers. Okay, so you have obviously 86 steel washers. I'm just going to draw this for example. All right. So the first probability is always going to be your original probabilities that you have determined here. So the first probability is P of steel, which is equal to 86 over 130. Which is going to be a value. All right, I'm not going to find the decimal point value. I'm just going to keep it this way for now. Tamam? This is our first choice. The second choice now, the second choice is if we copy paste this again, the second choice we have one of these steel balls is now outside. يعني our steel has now went from 86 to 85 and our n where did our n go? Then let me move these a bit down. So our n is now equal to not 130, it is equal to 129 لأن one washer has left the box. معناته our new P of steel is, what is the new number of steel inside? It is 85. What is our new n value? It is 129. So this is the probability of the second steel washer. Now again, if we copy paste this over here. So now we have 85 instead of 86, right? Or we had, I mean, 85 instead of 86. But here again, we want to remove, we have already removed in our second choice another steel washer. معناته the 85 has become now 84. And our new n, again, it went from n is equal to 129, it went to 128. This is what is meant by without replacement. So our probability has now went down to 83 over 128. Or sorry, 84. I don't know why I said 83. 84 over 128. So this is the first thing you need to understand. Understanding how to find your conditional probabilities, these are known as conditional probabilities, based on whether you have it without replacement or with replacement. If they mentioned with replacement, all of the choices is going to be 86 over 130. معناته they're putting the ball back in after every selection. So this is the case of choosing the first, choosing the second, and choosing the third probability. But let's read the question very carefully. What did they say? Determine that all three are steel washers. معناته our first choice is steel, oops كتبت سليت. زين our first choice is steel and our second choice is steel and our third choice is steel. لازم all of them they be steel. معناته what does and represent? It represents multiplication. Therefore, we are going to multiply the probabilities. So P of S1, 2, and 3, this is what I'm going to call them. So P of S1 times P of S2 times P of S3. That is going to be our probability of all steel. All right? This is the probability of all steel. So now we can just put in these numbers. So it's going to be equal to 86 over 130 times 85 over 129 times 84 over 128. And this is going to be equal to a number which doesn't really matter. The idea is what matters. So 84 divided by 130 times 129 times 128. You will get 119 over 416 or 0.286. All right. And this is, or you can also say this is 28.6% chance. This is your probability. I know in the question here I said 4 because I read it as 4 and then I started solving. بعدين لاحظت in the solution manual they're using 74 because they meant 74 instead of 4, but it doesn't matter what the number is. What matters is your solving is correct. It is the exact same method. The number is just going to be different, but that's fine. Just make sure you know how to apply it. Then, is this clear? You can do it using combination and permutation, but I prefer understanding it this way, and sometimes people will forget how to use combinations and permutations with this. Tamam? So this was easy, probability. Let's look at another probability question. So what do you guys think? Probability is easy or higher order differential equations is easy? أكيد higher order is easy صح؟ Probability is annoying. إنزين. A batch of 40 components contains 5, so okay, step by step. 40 components. معناته our n, the total number of components is 40. All right? Contains 5 which are defective. What does this mean? 5 which are defective. معناته إن 5 are bad. Best. Defective means they're not working well. We're going to call them bad. Before even moving on with the question, if 5 out of 40 are bad, that means 40 minus 5, all right, are going to be good. صح ولا لا? Which is equal to 35 are good. عندنا 5 that are bad من 40. الباقي they are good. They're opposites يعني طبعا. All right? So let's look at this from a probability standpoint. The probability of bad is equal to 5 over 40, right? Which is equal to a value, I think 0.125 divided by 40. Yes, 0.125. Okay? This is our probability of bad, 0.125 or 12.5%. Same thing. So if we want to find the probability of good, it is going to be not bad. صح ولا لا? It basically means that it is the probability of not bad, meaning B prime. And if it's good, it is not bad. And this basically means it is 1 minus the probability of bad. All right? 1 minus the probability of bad, which is equal to 1 minus 0.125. So the probability of good is equal to 1 minus 0.25 is 0.875, or in other words, 87.5%. And if you notice, the good and the bad, when you add them up, you get your full 100% number. All right. This is the idea of good and bad when you have a binomial case, which is either you have good or bad, yes or no. Yani basically you only have two selections. And now let's actually read what the question wants from us. If a component is drawn at random from the batch and tested, and then a second component is drawn at random, يعني عندنا two choices في النهاية. All right, so how many choices? We have a second one is also taken. So we have two choices or two selections. زين? Calculate the probability of having one defective component both with and without replacement. So we have two cases. First one is with, second one is without. All right. So again, same exact idea. So we have our probability of good or probability of bad. I think I did it in green. And then the probability of bad, which is equal to 1, where was it? 0.125. We have the probability of good to be equal to 0.875. And then actually I'm going to keep them in fraction form عشان you guys understand exactly how the numbers will change when we are doing replacement and no replacement. So it's 5 over 40 and this was 35 over 40. All right. And our n obviously is 40. Okay. So again, the question wants us to have two choices. So we're going to be selecting the first one and then first selection. And then we're going to have a second selection. All right. Let me put them a bit more in the middle, like this. So we're going to have a first selection, and then we're going to have a second selection. And what is the probability we're trying to find of having one defective component? So we only want only one defective component. What does that mean? What does only one defective component means? All right. We want it to be we want the probability, yani we want when, let's look at it from this choices selection. So let's say if we had our first selection to be defective, all right? So the probability of the first one being defective, where are my numbers? Okay, there we go. So the probability of the first one being defective is equal to what? 5 over 40, all right? But this means we want our second one to not be defective. So the probability of this one, it's going to be non-defective, which is probability of good, which is equal to, was it saying only one or only defective components? Drawn at random, calculate the probability of having one defective component. All right. So it says one. It doesn't say only having one. It says having one. This is where the trick will come. All right. So the probability of having one defective component, صراحة, I need to make sure what they mean by this. One defective component both with and without replacement. If the component drawn another for batch and tested and the second component is drawn at random, calculate the probability of having one defective component. One defective component basically means that the first one is going to be, yeah, all right. So one defective component means we want only one component to be defective. So only one defective. Then, meaning that the probability that the first one, the probability of it being defective is going to be P of B, which is the probability of a bad, which is the defective one, times the probability of a good component, all right? Which is equal to 35 over 40. The reason this is because we want to have the first choice to be 1 and we want it to be a bad component, and the second one we don't care about it at all. So the second one is going to be the exact same thing. So the probability of bad, 5 over 40 times the probability of good, which is 35 over 40. All right. And this is the case where we are not changing our numbers. Why are we not changing our numbers? لأن عندنا هني replacement. So basically, the first one, once the first one is picked out and is defective, that means the second one is not defective. All right. I mean, the second one is going to be a replacement, so you can pick it up again. Yani when you are taking one out of the bucket, all right, when you take one with replacement, when you take one outside, for the second case, you're going to be putting it back inside. All right. Meaning, in other words, we can find now our actual probability. So again, this is the probability of defective. I should say only defective, which is equal to the first case. All right. So this was the first choice, which is 5 over 40 times 35 over 40. All right. And we're going to have this, or يعني the first one is either this one is defective or the other one is defective, which is over here, which is the probability of 5 over 40 times 35 over 40. All right. This is the reason we have or in between the two of these is because you either want the first one to be the defective one or you want the second one to be your defective one. Tamam? Meaning that P defective, remember that or, all that means is it is plus. So it is 5 over 40 times 35 over 40 plus 5 over 40 times 35 over 40. And this is going to be your probability. You just multiply. So 5 over 40 times 35 over 40 plus 5 over 40 times 35 over 40, which is 0.21875, or you can say that this is 21.875% chance to get only one defective. All right. So again, what I did was we found out our probabilities. This is with replacement. Keep in mind, this is with replacement, meaning this is an independent event. معناته our first and second choices do not affect each other. Yani the second choice does not affect the first choice. All right. From where did you get the or? It's okay. I'll explain it again. So again, the idea here is we're trying to find only one of them being defective. We do not want the first and the second choice to be defective. That is why we are not keeping the probability of 5 over 40 by itself. The first choice is going to be 5 over 40 times the satisfactory or the good one. All right. So the bad times the good for the first one. And then the second one is going to be the bad, or it should be technically the good times the bad. Ashan, you get a better idea. So it's the probability of getting the good and not the bad. This is the whole idea. To be more clear, and Zain, to be more clear, if I mention it this way, if I mention it with this way. So remember when I said P of not bad is equal to P of good, صح? And the P of not good is going to be equal to the P of bad. All right? Okay? The way this will happen is, if we are looking at it again from the beginning, so we want the first one to be a good or a bad one. So the first one we want it to be P of B and not a bad one. All right. So and not a bad one. So it's going to be P of B prime or B naught. This is what I meant earlier. This is what is going to be P of G, because we want the first one to be, it has to be a bad one and not a good one. This is the whole point of this. Okay. So the P of bad and PB not or P of good. So in other ways, you can write it as P of B times P of good. And in the second case, we want it to be, it has to be good, and it has to be P of bad or P of not good. بما معناه we want this is going to be an and over here. There we go. So we want the second one, the second choice, to be a good, a satisfying one, an actual functioning one. And we want it to be, like earlier, we want it to be we want it to be multiplied with the defective one from the beginning. All right. This is the whole idea. So we have P of good times P of bad. All right. This is the whole point. This is how I arrange these. Then what is the idea is we want this to be either the first case scenario that we have here, where we get P of bad and good, or we want it to be the second case where we get P of good and then bad. Again, I think what's confusing you guys is the first and second over here. Technically, in this case, this is first possibility, you could say, all right? And this is your first choice and second choice. And this is your first choice and second choice. This is what is meant. And this is the second possibility. All right? So the first possibility is your first one being bad and your second one being good. Or you can have it the other way, where your first one is good and then your second one is not good or bad. All right? This is what is meant by this. So the idea here is your choices are here. And this or this and this, or you have these choices that are also possible, which is in the opposite way around. Then you just plug in all your numbers like you see here, or basically means plus, and then you find your value. Again, reminder, this is with replacement, meaning they are independent events. What about without replacement? All right, without replacement. In this case here, our values are going to slightly change. The concept is going to be the same, but the values are going to slightly change. How so? So our first probability is of bad is 5 over 40. So P of bad is 5 over 40. And the P of good is 35 over 40. All right. This is for the first choice. So when we're looking at our first choice, we want our first choice to be bad and the second choice to be good. We can either have this case, or we can have the first one be good and the second one be bad. All right. So these are the two options that we can have. So the first big one, which is the first is good, bad, and the second is good, or the other one is good and bad. But here, what will change? Once you take the probability, so the first one here is going to be P of B, which is 5 over 40. So once you take a bad component out, what will you be remaining with in your second one? So the P of G conditional B, this is how you usually write it down. All right, this is known as conditional probability, meaning it is depending on what will happen in B. This will be equal to the number of good components are still the same, which is 35, but you are dividing now by one less component, which is 39, because here now we are not having any replacement. If we look at our bucket, then if we're looking at all the 5 bad components over here and the multiple good components around it, once you take out, so here we have our n is equal to 40, all right? Once you take out one bad component, what you will be remaining with is now your n will become 39. But the number of good components are still the same inside. So you keep it that way. Therefore, this is going to be your probability of good, or, so I'm just going to put a line for now here, So this is now a new scenario. Yani it has nothing to do with this. This is a new scenario. Your first choice is good, meaning you're going to have the probability of good, which is the original good, which is 35 over 40. And again, and is just multiplication. Your second scenario now, P of bad is going to be equal to 5, because you have the same number of bad components inside, but the total number of components changed to 39. And this is for the case of a dependent scenario. And the OR is simply just plus. So now we can find the probability of only defective, or only one defective, I should say. It's going to be equal to 5 over 40 times 35 over 39 plus 35 over 40 times 5 over 39, meaning 5 times 35 divided by 40 times 39 plus 35 times 5 divided by 40 plus 39, which is the same answer. So it's going to give us 0.2244, or you can say that this is 22.44% chance. And this is how you would solve this without what you might call it, replacement. All right. Is this clear? خلينا نشوف الأسئلة اللي عندكم إياها. Again, the whole idea is understanding the question. So from the beginning, having one defective component, they meant having only one defective component. بما معناه that one of your components is going to be good, the other is going to be bad. All right? Meaning, if I show you guys with the bucket, because I think you guys understand better with the bucket. احنا عندنا 5, 1, 2, 3, 4, 5 bad components, and we have 35 good components. All right, I'm not going to draw all of them, but we have a lot of good components. All right, our n is equal to 40. الحين we have our first choice and our second choice. We want only, let me put it in red, only one bad. All right, which is the green one. Only one bad. So if we're talking about without replacement, and then we know that P of bad is equal to 5 over 40. And we know that, I'm pretty sure all of you know how I got P of bad and P of good are equal to these values, which is 35 over 40. Tamam? So as soon, if we're talking about with replacement, when we take this out, we are putting it back in. And then, but the idea here is our first choice is going to be, we're going to assume that it is a bad one. This first case. For our first case, we're going to assume it is a bad choice. معناته, we have 5 over 40 for the first one. All right? And then with replacement, it means we're putting it right back in. And now we're going to choose again. And now our second choice must be a good one. So we have to take out a good one. What is the probability of a good one? 35 over 40. All right? Again, I have to mention this clearly. This is for with replacement. Okay? And then we take the blue back in, and that's it. This is going to be our first possibility. This is the very first possibility that we have. يعني هاي أول طريقة ممكن ناخذ الكور. ولكن what if we first put our hand and first thing we got was a blue one or a good one? What if the first time we got, يعني, or what if this was the case? That the first one that we had, it was a good which is possible. This is another possibility. We had a good resistor or inductor. I don't even remember what the question was about. Good component. All right. And then, what if the first one we took out was a good component? معناته, the probability now is this one. The second one now, again, with replacement means putting it back in. Now the second one must be a bad component. So, and the second one has to be a bad component, which is a green component. So times 5 over 40. This is why we wrote both of these twice. This is how we wrote it down. So this is the first possibility, or this is our second possibility. لأن إحنا ما نبغى exactly our first choice to be the defective one. It can either be the first choice or our second choice, as long as we have exactly one choice. عشان كذي استوى هذا ضرب هذا plus هذا ضرب هذا. إنزين؟ This is for with replacement. In the case of without replacement, now we're going to talk about without replacement. The ball that we have here, or whatever the component, زين, let's look at our first scenario. Let's say we took out a defective one first, but we kept it out, خلاص. Now we are going to go select a second one. And the second one, we are selecting now our new n is no longer 40, n is now 39 for the second one. So it's going to be some number divided by 39. And what is that number? It is the number of good components we have inside here. Because we have to have a good component here. So it's going to be 35 over 39. And again, for a second scenario, what if we started by pulling out a good component? معناته the probability is 35 over 40. But now without replacement, we will be taking out another component as well. Meaning, now our n is 39 and the number of bad components will be the ones considered. معناته we have divided by 39, 5 bad components. All right? This is the whole idea of this question. Anyways, let's take a break so that you guys can شوي تريحوا مخكم and think about this a bit more. Let's take a break until 10 minutes. بنسوي 7 minutes. يلا. Break until 8:25 p.m. All right? Break until 8:25 p.m. and then we will continue with the mock test. Inshallah, we'll try to finish the next mock test as well if we have the time. Yes, I did solve higher differential, but I'll be solving more bad after this. Don't worry. ترى شوفوا, just so you guys know, يعني it's going to be a long session today. After I finish the mock test, we're going to be doing a lot of other activities as well, يعني higher order and all of that. So be ready, all right? يعني I know the timing, I said it's until 9, but I'm going to be here most probably until 11 trying to finish as much content with you guys as I can because I believe your exam is tomorrow, all right? So we're going to be taking some nice breaks in between عشان none of us go crazy. Don't worry about that. But for now, take a break until 8:25 and then we'll continue with this mock test and then we'll go take a look at the next one. I might solve it a bit quicker depending on the type of questions I see, but I just want to go through at least one of them properly and in detail. All right. All right, let us continue with the next question. The next question is very similar to this one, a bit simpler even. Okay. So the next question is, a lot contains 10 items, out of which 3 are defective. Okay. So our n is equal to 10. It contains 10 items. 3 of them are defective. So P of bad is equal to 3 over 10. All right, 3 of them are defective. Therefore, from the beginning, we can find that P of good is going to be equal to 7 over 10. In other words, another way to find it using probability is P of good is equal to P of not bad or not defective, which is equal to 1 minus P of bad. All right. And you will get 7 over 10. Okay. Either you can do it that way, or you can say that 3 plus 7 is going to be 10. So 3 are bad out of 10. What is remaining? 7, which will be good. 3 items are chosen from the lot, one after another, at random without replacement. All right, so here it mentions that it is without replacement, meaning that we are dealing with a dependent event. So without replacement, meaning it is dependent, and after the numbers are going to be changing. You're not going to be using the same probabilities all over. So how many choices we have? We have 3 choices. Find the probability that all 3 are defective. Very simple. We want all of them to be defective. So the first choice, second choice, and third. Right? If we use, so let us do it in terms of the box, so you guys can see what it would look like without replacement. All right. So this is a dependent event, meaning that there is no replacement. So we have 3 that are bad, and 1, 2, 3, 4, 5, 6, 7 that are good. Okay. Meaning, and this is what the box looks like for each one, for now at least. So let's start with the first one. The first one, we want to remember the probability that we're looking for is the probability of all bad or defective. معناته the first one, always the first probability, it's just going to be the actual probability that we found, which is equal to 3 over 10. The probability of bad that we found, which is 3 over 10. All right. And then that means we have already removed it in the second box. So we have taken it out in the second box. All right. Because we are not replacing it, here we had n is equal to 10. Now here our n is equal to 9, and the number of bad resistors inside have become 2. So now P of bad 2 is going to be 2 over 9, which is the number of bad resistors over the number of total resistors or components or whatever. All right. Same thing again. So now we have already taken one out from the previous one. So it's going to look like this. Now again, we have taken an extra one out for the third one. All right. So the third choice will be out of this. These are our first 2 choices. Okay. So I'm just going to write that down. This is our first choice or first selection. This is our second selection. Okay. In this case, this was our first selection. So now again, how many are bad remaining inside here? So the bad, now we only have one of them that is bad. And the total has also changed from 9. Now it is only 8 inside of this box. معناته the probability of this is going to be 1 over 9. And because we want all of them to be bad, it means the first one and the second one, and the third one. In other words, it is multiplication. And that's it. So the probability of all bad is going to be equal to 3 over 10 times 2 over 9 times 1 over 9. Sorry, 1 over 8. This is 8. I just noticed it changes to 8. So it's going to be 1 over 8. And this is going to be equal to 1 over 120, or in other words, it is 8.333 times 10 to the minus 3. Okay? And that's it. This is how you would solve such a question. Very straightforward, very direct. And that's pretty much it for this question. Let's move on to the next question, which is the last question, and it is our statistics question. All right. So here the question says, determine the frequency distribution, or sorry, the frequency distribution for the value of resistance in ohms is shown below, which is in this table, and they want us to find the mean value of resistance and the standard deviation. All right. So they want us to find the mean and the standard deviation. So the way you're going to do this is, obviously, this is going to be your data, and this is your frequency. All right. If you notice here, we have a range of data. How do you tackle a range of data? So the first thing you're going to do is you're going to be extending this table, and let us do that. So we usually are dealing with not a class or not an interval. We're usually dealing with a single value, but in this case, we have a class. So the way to do this is, the first step you're going to find is your midpoint, which we will call X, which is our midpoint. How do you find your midpoint? You're going to take your lower range and your upper range, and you're going to add them and divide by 2. And you're going to do this for all of the cases that we see here. All right? Over 2. And so on for all of them. Meaning, X midpoint for the first one is going to be 20.5 plus 20.9. Divide by 2. This is going to give us 20.7 for the first one. All right? And you will do the exact same thing for all the remaining ones. So the second one is going to be 21.1, 21.4. It's going to be 21.2, if I am not mistaken. So 21.1 plus 21.4 divided by 2. It's going to be 21.25. All right. The next one is going to be 21.25. The next one is going to be 21.5 and 21.9. That is 21.7. The one after that is going to be 22.2. The last two are going to be 22.7 and 23.2. All right. This is how you will find your midpoint values. You're just going to add the 2 and then divide by 2, and this is how you find your midpoint. Once you find your midpoint, now you can apply finding your average and standard deviation using these X values. So we don't care about the data value anymore. We have found the midpoint, and this will be our X value. So in the question, it already says we have a total of 48 resistors. What does that mean? It means our sum over here of the frequency is equal to 48 resistors, or sometimes you call this N, which is 48 resistors. All right. So a total of 48 resistors. How do we find the average? Finding average is, first thing you need to do is you need to find your sum of your midpoint here, which will be equal to, you have to add up all the values of your midpoint, which is 20.7 plus 21.25 plus 21.7 plus 22.2 plus 22.7 plus 23.2, which is going to give us 131.75. Okay? Once we find the sum, remember that average, okay, I'm pretty sure it's also given in the equation sheet, but just in case, average, also known as x bar, is equal to the summation of f times x over summation of f, or sometimes you can just say it's summation of f times x over n. All right. So we need to find f times x. So that's what we're going to do now. We are going to have f times x over here, and we are going to start multiplying to find the values. So here we have 3, here we have 20.7. So we're going to be multiplying these two values. All right. So it's going to be 3 times 20.7. The value of that is 3 times 20.7, 62.1. And you're going to be doing the same for all the other values. So here we're going to have 202, 212.5. 21.7 times 11 is 238.7. 22.2 times 13. And that is going to be 288.6. 22.7 times 9, that is going to be 204.3. And 23.2 times 2, that is going to be 46.4. And now we are going to find the sum of all these values. There was no point in finding the sum of the midpoint, actually. That was for single values, not frequency values. What we need to actually find the sum of is this, all the values in here. In other words, we're going to be adding 62.1 plus 212.5 plus 238.7 plus 288.6 plus 204.3 plus 46.4. You get 1052.6. And this will be now our value here for summation of fx. And we have already found our n from the beginning, or our sigma f. It's the same thing. So this is going to be equal to the x average, or our mean, is 1052.6 divided by 48. Therefore, our average is equal to, divide this by 48, you're going to get 21.93 ohms. We are talking about resistors, right? Yes, resistance in ohms. So this is going to be in ohms. So your average ohm value is 21.93, or the mean value. Okay. Now, this is for finding average, which was very straightforward. What about standard deviation? Again, standard deviation, and the equation is also most probably going to be given to you guys, but just in case, standard deviation is equal to the square root of the summation of f times x minus x bar squared divided by our sigma f, or in other words, it's the same thing, but it's over n. All right, so sigma f into x minus x bar squared. So how do you do this? Again, you're just going to extend your table over here, and you're going to add the values one by one. So the first one we need to find is x minus x bar. So that's what we are going to do. We're going to do x minus x bar. All right. What does this mean? So we have found our x bar value, which is our mean value, 21.93. And we are going to subtract our x value over here. So it's going to be 20.7 minus our mean value, which is 21.93. Okay, so minus 21.93. This is what we are going to be doing for all of them. So the next one is going to be 21.25 minus 21.93. Next one is going to be 21.7 minus 21.93. Next one is 22.2 minus 21.93, 22.7 minus 21.93, and the last one is 23.2 minus 21.93. And these values now you're going to be squaring them. So x minus x bar, you're going to be squaring them. So it's going to be the same exact values that we have here. or actually let me calculate them. So 20.7 minus 21.93, you get minus 1 minus 1.23 squared. All right, 21.25 minus 21.93. Again, you get minus 0.68 squared. Next one is 21.7 minus 21.93. You get negative 0.23 squared. 22.2 minus 21.93. You get 0.27 and squared. 22.7 minus 21.93. You get 0.77 and squared. And the last one is 23.2 minus 21.93. You get 1.27 and you will square it. The last step would be multiplying all of this by f. So f times x minus x bar squared, which is just the multiplication of this purple part by, let's keep it purple. So we're going to be multiplying this with our frequency that we got over here. The same thing for the rest. We're going to be multiplying them with all these frequencies. All right, so each one you're going to be multiplying it with its own row, and you will find your answer for it. So the first one is 3 times negative 1.23 squared. That is equal to 4.5387. Next one is negative 0.68 squared times 10, which is negative. Why is it negative? It shouldn't be negative. It's positive 4.624. It's actually good that I got it negative, so I can explain one more point. Keep in mind when you are squaring the value has to be in between brackets, and the actual final answer should be a positive number. Then the negative is in the brackets, meaning when you square a negative value, you get a positive value. Just a reminder for that. All right. So 0.23 or negative 0.23 squared times 11, you get 0.5819. 0.27 squared times 13, you get 0.9477. 9 times 0.77 squared, you get 5.3361. And the last one, which is 2 times 1.27 squared, you get 3.2258. And then you will add up all the numbers that we have just calculated, which is 4.5387 plus 4.624 plus 0.5819 plus 0.9477 plus 5.3361 plus 3.2258. The summation, I get 19.2542. All right. And this summation value that we have finally found, this value is going to be going in for your numerator here in this equation. So it's equal to square root of 19.2542 divided by our n, which is 48. Therefore, our standard deviation is going to be equal to 48, 0.6333. I'm not sure if this is the actual answer, if it's similar to the, yeah, okay, all right, it's fine. So it is 0.6333. Again, it depends on the accuracy you are taking. That's why the actual answer is 0.645 based on the solution, but it all depends on the accuracy you are taking with the decimals and all of that. As long as you're within the correct range, this will be your answer. Any questions about this, about filling out the table? It's clear, right? You can do it without the table. Yani you can, if you are comfortable, do all of this yani from here. After you find all of this, you can do this all in one go if you like. but it gets confusing. فيفضل يعني تسوون table step by step. Even me, I don't like doing it one shot لأن مرات أخربط بين الأرقام. I forget an F somewhere, or I forget the squared, or I put the minus outside, or whatever happens. That's why you should do it step by step. And this is it for the first mock test. Let's start with the second mock test and go back all the way to ordinary differential equations again. So let me call this M2 final mock 2, right? So let's look at the first question from the other mock test. Again, it is a second order differential equation. By applying Kirchhoff's voltage law to a circuit, we obtain the following differential equation, which is 4i double prime plus 36i prime. Oh, sorry, 36i, there's no prime, equals 24i prime. When you see it in this form, all you have to do is just move your 24 to the other side. So you're going to get 4i double prime minus 24i prime plus 36i is equal to 0. And that's it. That's the whole trick for this question, Yani. Just make sure that your right-hand side is equal to 0. Then you can write your auxiliary equation, which is 4r squared minus 24r plus 36 is equal to 0. Then you're going to do your R1, 2, which is equal to, for a quadratic equation, minus b, which is minus 24, because b is already negative. So this is our b value, this is our a value, and this is our c value. All right, plus or minus the square root of, so again, R1, 2, this is equal to the quadratic equation, just in case you guys don't remember it, plus or minus b squared minus 4ac divided by 2a. All right, but I'm just plugging in the values directly. So 24 squared, which is 576, minus 4 times a times c. So a is 4 and c is 36, divided by 2 times a, which is 2 times 4. Simplifying this, we get negative and negative becomes positive. 24 plus or minus the square root of, so 4 times 4 times 36. We are going to get 576 minus 576 in the middle here over 8. So in other words, this is going to be 0, right? So this is the case where we have one root, or also known as a repeated root. Okay, so our R1 is going to be equal to 24 over 8, which is equal to, or our R12 is 24 divided by 8, which is 3. All right. When we have the case of one repeated root, we are going to use the equation for the repeated root for case 2 usually. So y is equal to c1 e to the power of rx. The reason it's just r is because we only have one value for r, plus c2 x e to the power of rx. We're going to have to add an extra x here in the case of a repeated root. Keep in mind, this is just the general, not the general solution, but the general form. The general solution, we need to make sure that if you notice here we have di by dt, not dy by dx. All right, so we're going to replace our y with I, and our x with t. That's all I'm going to be doing here. Okay, so to do that, instead of y, we're going to put I is equal to c1 e to the power of r, which is 3, t instead of x, plus c2 t instead of x e to the power of 3 t instead of x. And this is your general solution. All right, this is your general solution. Now, we have found our general solution, but the question gave us parameters or gave us initial values. It told us that when t is equal to 0, I is equal to 0, and di by dt is equal to 3. So it said, first, when t is equal to 0, I is equal to 0. And the second, when t is equal to 0, I is equal to, or di by dt, which is also known as I prime, is equal to 3. So what do we do in this case? First, let us substitute for the first case because it is t and I, so we can do that directly. So for the first case, we know that t equals 0, I equals 0. All right. معناته we're going to substitute for I 0 is equal to C1 e to the power of 3 times 0 plus C2 times 0, which is for t, e to the power of 3 times 0. All right. If you notice here, we're going to have 0 on the left side. E to the power of 0 is 1, so it's just C1 times 1, plus C2 times 0 is 0, so this entire value becomes 0. So in other words, C1, let me write it on the side. So C1 is equal to 0. All right? This is the first value that we have found, that our C1 value is equal to 0. All right? When our C1 value is equal to 0, now we need to find our C2 value using our second given values or initial values. However, here we have I prime, so we need to find the differentiation of this general solution. So we need to find I prime, which is equal to, for the first part, it is C1 e power 3t, so it becomes 3 C1 e to the power of 3t, plus, in here, let me move this a bit down, and here we have a product rule where this is u and this is v. All right, so we find our u prime, which is equal to C2, and our v prime, which is equal to e to the power of 3t becomes 3 e power 3t. معناته the differentiation of this, all right, is going to be u prime v plus u v prime. All right, so that's what we are going to be plugging in here, our differentiation for that. So the first one is u prime, which is C2. Our second one is v, which is e to the power of 3t, plus u, which is C2t, v prime, which is 3e 3t. All right, and that's it. Keep it in this form. Do not simplify anything yet. Now we are going to plug in our initial conditions, and we are also going to plug in the value for C1 because we have already found it. So we might as well get rid of some constants. So we also know and C1 equal 0. So let us plug all of these inside. So first thing, I prime is equal to 3. So 3 is equal to 3 C1. C1 is 0. E to the power of 3 times t, which is 0, plus C2, which we are trying to find, e to the power of 3 into 0 for time, plus C2 times time, which is also 0, into 3e3t, which is also 0. Okay? And that's it. Now we simplify. So we have 3 is equal to, actually, so that there's no confusion, these values are, let me just copy paste this. These values over here, they are the time. They're not C1. I know you guys know this, but just in case, so that there's no confusion, this is all times 0. All right, from time, because time is 0 and not C1. Okay, so simplifying, 0 times all of this becomes 0, plus C2 times e to the power of 3 times 0, which is e to the power of 0, which is 1, plus C2 times 0. All right, C2 times 0, which is time. So this is just going to be all 0 on the right side as well. معناته we're going to get that C2 is equal to 3. Now we can plug it into our general solution that we have found from the very beginning to find our particular solution. So for C1, we found it to be 0. And for C2, we found it to be 3. So in other words, I is equal to, this whole term is going to become 0. So we're going to be left with 3t e 3t, and this is your final particular solution. All right, clear? How do you know when to use product rule? Product rule basically is going to be applied in two cases. When you have this form like here, where you have t times e to the power of 3t, or in the case of complex, where you're going to get e to the power of alpha x into cosine and sine. All right, so this is when you will be applying product rule. For this one, for the t e3t, all right? So this case, because we have t, which is a function, or c2t, which is our first function, and then we have e to the power 3t, which is our second function. All right, so this is the first time. The other time you will use it is when you have e alpha x cosine plus sine. In this case as well, you will be applying it. Okay, so those are the two times you'll be using this. Let's look at the second question. The second question is actually we have oh no, never mind, it's different. All right, let's look at the second question. It's also second order. Very easy, very straightforward. Let's go through it very quickly. So solve the differential equation. Again, second order. Look at how quick you can solve this. All right, I'm going to go through this very, very quickly. All right, if you want, you can time me. So the first thing you're going to do, and I'm going to write the full steps. I'm not going to use calculator for mode 5.3 and that. All right. So the first step you're going to do is, if you want to simplify it for your eyes, you're going to do this plus 9y equals 0. All right, make it in y double prime, y prime. Then you find your auxiliary equation, which is r squared plus 4r plus 9 equal 0. All right. This is going to give me r12, which is equal to minus 4 plus or minus the square 4, which is 16 minus 36. All right, divided by 2. All right, 16 minus 36. I know this is going to be complex already. So r12 is equal to minus 4 plus or minus 36 square root of minus 20, or square root of 20, I should say. This is going to be 2 square root 5 I, all right, divided by 2. Okay, so our R1 value is going to be equal to minus 4 plus 2 square root 5 over 2 I, of course, and my R2 value is equal to minus 4 minus 2 square root 5 I over 2. You do not need to write it this way. Okay, you can simplify it. You can keep it in R12 form because it is a complex root, and they're always going to be conjugates. All right, so you can keep it in this form where it's minus 2 plus or minus square root 5 I. All I did was we have 4, 2, and 2, so I divided everything by 2 at the top, so we get this R12. And that's it. What's my general solution? The general solution for y is going to be e to the power of alpha x times cosine, or C1 cosine, I should say, beta x plus C2 sine beta x. And now we plug in our values. E to the power alpha, remember this is our alpha, and this is our beta. All right, so it is negative 2x into C1 cosine. What is our beta? Square root 5 x plus C2 sine square root 5 x. And that is your general solution, and you're done with this entire question. All right. Very easy. It's very straightforward. All you have to do is just know how the steps are. If you notice, they're very short. The only time it will become a bit longer is particular, but it's not difficult. You just have to apply all of it يعني while knowing what you're doing. يعني make sure you're not making mistakes in differentiation and copying numbers and the substitution and all of that. So this is our general solution. All right, how long did that take me? Like 2 minutes? Then, so 2 minutes 8 seconds. There you go. يعني I got how many marks is on this? 25. 4 marks out of 20. All right, not bad. This is like 20% of the exam, or maybe 15% of the exam in 2 minutes solved. All right. The higher order is exactly the same one that we did in the previous mock, so I'm not going to go through that again. Let's look at the statistics part now. All right. Again, it is table. I am going to go through it again very quickly, just to make sure you guys understand the concept very well. So they gave us this table, which is classes and frequencies. And the question was, calculate the mean and the standard deviation using the following data. Again, when you have a class, all you're going to do is you're going to be extending the table. Just going to be putting a few lines. I'm not going to put lines everywhere. Here, and at the end. Okay, so the first thing you're going to find is x midpoint. All right, x midpoint is 1 plus 10 over 2. Okay, that is going to be your x midpoint. So 1 plus 10 over 2, that is 11 over 2, which is 5.5. This is going to be 15. This is going to be 25. This is going to be 35. This is going to be 45. And this is going to be 55. The middle number between these two. And you don't even need to calculate if you know how to do it directly. So this is the first thing you do. Then you put a line and you find your XF. All right. So this is our F, the frequency. So now we find XF, which is 5.5 times 13, giving us 71.5. 15 times 20 giving us 300. 25 times 27 giving us 675. 7 times 35 gives us 245. 15 times 45 is 675. 55 times 11, that's 500, 600, 605. All right. That's it. Once you do that, now you do the summation. The summation of the XF and the summation of F. Why are we doing this? Because we are trying to find x bar, which is our average, which is equal to the summation of f times x divided by sigma f. So 13 plus 20 plus 27 plus 7 plus 15 plus 11 is 93. 71.5 plus 300 plus 675 plus 245 plus 675 plus 605. That gives us 2,571.5. All right. And now, simply all you just have to do is plug in these numbers. So this will go in here, and this will go in here. Okay. So this is going to be 2571.5 over 93, which is equal to, divide by 93, 27.65, and this is our average value. When it comes to standard deviation, remember the equation is square root of the summation of f x minus x bar squared over n. All right, or instead of n, we could say sigma f. And then we already have the value of sigma f, which is the blue. We already have it, but now we need to find this entire thing. Let me show you, if you want to do it all in one table, how it will look like, but it will be messy. So what are we trying to find? We're trying to find f times x minus x bar squared. So for the first one, your f is 13 times x is 5.5 minus x bar is, we have already found to be 27.65 squared. And you're going to do the same for everyone else. So 20, the value is 15 for x minus 27.65 squared. The next one is 27. What's our x value? 25 minus 27.65 squared. Next one, the frequency is 7 into 35 minus our midpoint squared. Next one, 15 into 45 minus 27.65 squared. Last one, 11 into 55 minus 27.65 squared. Again, where did I get all these values? So these values over here is our frequencies, right? And these values over here, what color did I not use? Okay, red. And these values over here are these values. Okay. And the mean is what we have already found here. And then we just squared all of it. Once you find the answer for each one, you can just add them all up. You can also add them all up directly in the calculator, but I do not recommend that. So what you can do is you can just say, find the value for each one and then just add them up. So it's going to be 13 into 5.5 minus 27.65 squared. That's our first value, which is 6378.09. Yes, I know this method is a bit faster, but you can also have room for error. That's why I try to avoid it. Okay, so 3200.45. 27 into 25 minus 27.65 squared, which is 189.6075. 35 minus 27.65 squared times 7. 378.1575. 45 minus 27.65 squared times 15. This is 4515.3375. And the last one, 11 into 55 minus 27.65 squared. It is 8228.2475. And now we are going to add up all of these numbers. 415.3375 plus 378.1575 plus 189.6075 plus 3200.45 plus 6378.09, which is 24464.7325. This is our sigma, which is going to be, instead of this value over here, so it's equal to the square root of our sigma f is 93, and the numerator is 24464.7325. This will give us that our sigma is equal to, divide by 93, square root of that is 16.219. All right, that's how you would solve it in one step. I know it says 15.69 in the solutions, but here they were rounding up to 1 decimal point, but me, I kept all my decimals. That's why it's a bit different. If anything, mine is more accurate. All right, but it doesn't matter that much. As long as you have it within a specific range and your solution is correct, your solving is correct, you're going to get your grades. Clear so far? All right. Moving on, I think statistics should be your freest mark. يعني بيكون ربع العلامة من الامتحان على statistics. It should be your free mark no matter what. حرام إذا خسرتوا علامات في statistics. Now, going back to probability again. So probability, let's look at this question. The probability of event A happening is 0.81, and the probability, this is very easy. So event A is going to be our red. So event A is 0.81. So the probability of A happening is 0.81. And the probability of B happening, so event B happening, is 0.55. If you notice here, B and A are completely different events. Oops, this is actually here. So B and A they have nothing to do with each other directly. يعني A ما يخصها في B. Why? Because when you add the probability of A with B, you get a value larger than 1. So these have nothing to do with each other directly. All right, they're just probabilities of a specific event. زين. For example, this is the probability of it raining tomorrow, and this is the probability of the entire class failing tomorrow. And then it has nothing to do with each other. All right? مبقطة. Calculate the probabilities of first, part A. Both A and B happening. A and B happening. So we want the probability of A and B. What does this mean? It's the probability of A and is multiplication, the probability of B. So simply it's 0.081 times 0.55. And this is going to be 0.55 into 0.81, 0.4455, or 44.55% chance. All right. So this is for part A. When you see and, just know that means it's multiplication. So when you see and, you multiply. All right. Part B. Calculate only event A happening. Remember, what does only event A happening? When we are saying only A, all right, this is what we are saying. We want only A. So the P of only A. This basically means the probability of A happening and the probability of B not happening. All right. So now what do we need to find? We need to find our B naught. We need to find our probability of B naught. If you remember, if I make some space here as well, so the probability of A naught is going to be equal to 1 minus the probability of A, which is 1 minus 0.81, meaning the probability of A naught is 0.19. All right? This is how you'd find the probability of naught. Same thing for B. Probability of B naught is going to be equal to 1 minus the probability of B happening. معناته it's equal to 1 minus 0.55. So the probability of B naught is equal to 0.45. All right. So now we can just plug in our 0.45 here, because when we're talking about only A happening, we only want A to happen and B not to happen. So this is going to be 0.81, which is the probability of A, and means multiplication, and the probability of B not, as we have found it here, is 0.45. So times 0.45, this is going to be equal to 0.81 times 0.45. You get 0.3645. All right. Let's look at part C. Only event B happening. So now the case is of only B happening, meaning that we want B to happen and we want A not to happen. Okay? Meaning we're gonna you have 0.55, which is the probability of B happening, and probability of A not happening is 0.19. So times 0.19, this is gonna be equal to 0.1045. All right, or this can be 36.45% of not happening. This is 10.45% of not happening. Okay. That's it for probability for this question. Pretty sure most of you already know. Yeah, that's pretty much it. Let's look at the next question. All right, so it's also another probability question with a lot of words, and this is including permutation and combination, which we will see in a bit. As soon as I saw lottery, I knew it was going to be permutations and combinations. Then, so first, let us read. In a certain state's lottery يعني سحوبات زين 40 balls numbered 1 through 40. فأول شيء, how many balls we have? We have 40 balls. So the number of choices we have, our n, is 40. They are numbered 1 through 40, so their values are 1 to 40 as well, which is nice, are placed in a machine, and 6 of them are drawn at random. So our R is 6 يعني احنا شلينا 6 from 40. 6 of them are drawn at random. If the 6 numbers drawn match the numbers that the player had chosen, the player wins $10,000. In this lottery, the order with the numbers are drawn. شو هالإنجليزي؟ The order the numbers are drawn in. Okay. The order the numbers are drawn in does matters. يعني أشكرا معطينكم إياها. Order matters. يعني it is important what is the first number, what is the second number. Since they said order matters, instantly you know you're going to be using permutation instead of combination. اللي هو P instead of C. All right? Because order matters. Compute the probability that you win the $1 million prize if you purchase a single lottery ticket. تو يقولون 10,000 الحين يقول 1 million. I don't know. المهم انزين مو مهم الارقام. أول شيء how can we find the possibilities؟ يعني أول شيء what is the chance of me getting one out of how many numbers؟ يعني how many possibilities are there to choose from؟ يعني how many possible numbers can I choose 6 out of 40? How do we do that? Since order matters, it is going to be N P R, which in this case is 40 P6, which you just put into the calculator. 40p6, which is going to be a humongous number اللي هو 27636333600. So out of 2.7 billion combinations, one of these numbers is going to win me the $1 million prize. What does that mean? معناته I have a chance of 1 out of all these number of possibilities اللي هو 27636333600 of winning. زين? Therefore, the probability of winning is going to be 1 divided by this huge number, which is 3.618 times 10 to the negative 10. يعني بما معناه 0.000000003% chance بعد مو هذا percentage chance of me winning $1 million. خلى المليون حقهم ما بيعور راسي وياهم. بس this is how you would solve such a question. Make sure you know what your N is. Make sure you know what your R is. Make sure you know if order matters or does not matter. In this case, it clearly states that it does. And then find the total possible permutations that you can have, يعني all the different random numbers that you can put in. And if you have only one winning prize, it is going to be 1 divided by all of this. Let's say they said if you compute the purchased 20 tickets with different random numbers. So if you purchase 20 tickets, you're going to have 20 out of this many of chance of winning. All right? This is how you would solve such a question. I hope this session was helpful. We have went through both mock tests, and I want to know from you guys الحين, what do you guys find more difficult, probability and statistics, or أو بلا صح probability statistics no one should find difficult at this point, probability or higher order? I want to see the votes in the chat. Probability or higher order?